Hello everyone, welcome to my channel. Today we will talk about a new topic, surface chemistry. In this surface chemistry, the very first thing which we should understand is adsorption. Now what is adsorption? The accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is called adsorption. Now in the adsorption, there are two more terms involved. The first one is adsorbate and another one is adsorbent. So what is adsorbate? Simply the molecular species or the substance which concentrates or accumulates at the surface is called adsorbate, and the material on the surface of which the adsorption takes place is called adsorbent. Now, the very simple example of adsorption, adsorbate and adsorbent is when we write on a board with a chalk. Then the chalk will be adsorbate, board will be the adsorbent, and chalk gets adsorbed on the board. So it is the simplest example of adsorption. The next thing is action of adsorption. Means few examples which will be illustrating the phenomenon of adsorption are: number 1, if a gas like oxygen, hydrogen, CO, Cl2, etc. are taken in a closed vessel, and in that vessel if we add little bit of powdered charcoal, we will observe that the pressure of the gas in the enclosed vessel will decrease. The gas molecules will start concentrating at the surface of charcoal. That means gases are adsorbed at the surface of charcoal. Number 2, in a solution of an organic dye, say methylene blue, when animal charcoal is added and the solution is shaken, then we will observe that the filtrate turns colorless. Why? Because molecules of the dye have been accumulated on the surface of charcoal. Number 3, aqueous solution of raw sugar, when passed over beds of animal charcoal, then it becomes colorless. Why? Because the impurities, they get adsorbed on the surface of charcoal. Number 4, the air becomes dry in the presence of silica gel, because the water molecules, they get adsorbed on the silica gel. Number 5, adsorption is a reversible process. The reverse of adsorption is called desorption. So what is desorption? That is simply the process of removing an adsorbed substance from a surface on which it is adsorbed is called desorption. Though the desorption takes place of its own, but it can be increased by increasing the temperature. Now what happens when we increase the temperature? The energy absorbed will be weakening the forces binding the molecules of adsorbent and the adsorbate. As a result, the latter gets released from the surface. Now the next is difference between adsorption and absorption. So what is the main difference between adsorption and absorption? So what is absorption first of all? The phenomenon as a result of which the molecular species of one substance are accumulated on the surface as well as inside. That is throughout the substance which takes them. So that is called the absorption. Whereas adsorption is the surface phenomenon. Means here the molecules will accumulate more on the surface than in the bulk. So adsorption is the surface phenomenon, whereas absorption is the bulk phenomenon. Bulk means here the molecules will be more inside the liquid than at the surface of the liquid. Now a simple distinguish can be made between absorption and adsorption by considering an example of water vapors. Water vapors are absorbed by anhydrous calcium chloride, but they get adsorbed by silica gel. In other words, in adsorption, the concentration of the adsorbate increases only at the surface of the adsorbent, while in absorption, the molecules will enter into the bulk. And sometimes they both can take place simultaneously. And when we are not able to distinguish between adsorption and absorption, since both are taking place simultaneously, then the term used is sorption. Now, so now we can make out the difference between adsorption and absorption as adsorption is the surface phenomenon, whereas absorption is the bulk phenomenon. In adsorption, concentration on the surface of the adsorbent is different from that in the bulk. Whereas in absorption, the concentration is same throughout the material. Adsorption is rapid in the beginning and its rate slowly decreases, but absorption proceeds at uniform rate. Coming to now the mechanism of adsorption. So what is the mechanism of adsorption? A very simple mechanism of adsorption is that in adsorption, since it is a surface phenomenon, so atoms in a solid, they are held by certain binding forces. These binding forces are mainly the van der Waals forces or maybe even some chemical forces. Now there are some unutilized or unbalanced forces present on the surface. These unbalanced forces make it very reactive. So when a solid substance is broken into two or more pieces, then new surfaces get formed. As a result, the number of unbalanced forces becomes more. So more the number of unbalanced forces, more will be the number of active centers or free valencies which can attract the adsorbate molecule. So that's why it is always better to take the adsorbent in the finely powdered form. Because on these unbalanced forces, atoms or molecules on the surface, they will have maximum tendency to attract and retain the molecules of gases when they come in contact with the surface. So that's why it leads to higher concentration of any particular species at the surface than in the bulk. The extent of adsorption increases with increase of surface area per unit mass of the adsorbent at a given temperature and pressure. Now some examples. Now let us talk about the thermodynamic feasibility of adsorption. Now there is another very important term related with the adsorption, and the term is enthalpy of adsorption. So what is this enthalpy of adsorption or heat of adsorption? The change in enthalpy taking place for the adsorption of 1 mole of the adsorbate on the surface of adsorbent. That change in enthalpy is called enthalpy of adsorption. Now, since some energy is always released in the adsorption process, so adsorption is always accompanied by decrease in enthalpy. And since molecules are adsorbed on the surface, so their randomness always decreases. So that means during adsorption, delta H decreases as well as delta S, which is the change in randomness or change in entropy, that also decreases. For a process to be spontaneous according to thermodynamics, delta G is equal to delta H minus D delta S. So delta G should be negative for a process to be spontaneous. Now here delta G can be negative only if delta H will be sufficiently highly negative. It should be sufficiently high negative as compared to T delta S, since T delta S minus T delta S is going to be positive. Thus, in an adsorption process which is spontaneous, a combination of these two factors makes delta G negative. So, which two factors? One is the enthalpy, another is the randomness. During the adsorption, delta H as well as delta S decreases. So, both of these are negative. So, in order to make the process spontaneous, delta G has to be negative, which is only possible if delta H is much greater than T delta S. Now what happens as the adsorption proceeds? Delta H becomes less and less negative. Hence, a stage will come or appear when delta H will become equal to T delta S. Now in this case, when delta H is equal to T delta S, delta G becomes 0. That means equilibrium will be attained. So when delta G equals to 0, equilibrium is achieved. When delta G is negative, process is spontaneous. When delta G is positive, then process is non-spontaneous. After this, let us now come to types of adsorption. There are mainly two types of adsorption of gases on solid. Number 1, physical adsorption. Number 2, chemical adsorption. Now, if accumulation of gas on the surface of solid occurs on account of weak van der Waals forces, then it is called physical adsorption or physisorption, or sometimes van der Waals adsorption also. Now, when the gas molecules or atoms are held to the solid surface by some chemical bonds, then the adsorption is called chemical adsorption or chemisorption. The chemical bonds, they may be covalent or they may be ionic. Chemisorption involves a high energy of activation and is therefore often referred to as activated adsorption. Sometimes these two processes, they can occur simultaneously, and it is not easy to ascertain the type of adsorption. A physical adsorption at low temperature may pass into chemisorption at the higher temperature. For example, dihydrogen. Now, dihydrogen is first adsorbed on the nickel by van der Waals forces. So, it is simply the physical adsorption. But as the temperature increases, molecules of hydrogen will dissociate. They will form hydrogen atoms. Now, these hydrogen atoms are held on the surface by the chemical bonds. So, now the physical adsorption gets converted into chemical adsorption at high temperature. Now, what are the characteristics of physisorption? The main characteristics of physisorption are: number 1, lack of specificity. Now, physisorption is not very nature specific. A given surface of an adsorbent does not show any preference for a particular gas, as the van der Waals forces are universal. Number 2, nature of the adsorbate. The amount of the gas adsorbed by a solid depends on the nature of the gas. In general, easily liquefiable gases, they are readily adsorbed as van der Waals forces are stronger near the critical temperature. Number 3, reversible nature. Physical adsorption of a gas by a solid is generally reversible. Thus, more of the gas is adsorbed when pressure is increased as the volume of the gas decreases, and the gas can be removed by decreasing the pressure. Since the adsorption process is exothermic, so the physical adsorption occurs readily at low temperature and decreases with increase in temperature according to Le-Chatelier's principle. Number 4 is surface area of adsorbent. The extent of adsorption increases with increase in the surface area. That's why we use finely divided nickel, platinum or palladium metals and highly porous substances having large surface area. Number 5, enthalpy of adsorption. Now, physical adsorption is undoubtedly an exothermic process, but its enthalpy of adsorption is quite low. The energy requirement is 20 to 40 kilojoules per mole. This much of enthalpy is released. Why? Because because the attraction between gaseous molecules and the solid surface is very, very weak. That is simply weak van der Waals forces. Now the next is characteristics of chemisorption. Chemisorption is highly specific. So number 1 is high specificity. It is highly specific and it will only occur if there is some possibility of chemical bonding between adsorbent and adsorbate. Number 2, it is irreversible. Chemisorption involves compound formation, that's why it is irreversible. Chemisorption is also an exothermic process, but the process is very slow at low temperature on account of high energy of activation. So, in physisorption of a gas adsorbed at low temperature may change to chemisorption at a high temperature, as I told in case of hydrogen gas. Now the third point is surface area. Like physical adsorption, chemisorption also increases with increase of surface area of the adsorbent. Here the enthalpy of adsorption is very high and it lies in a range of 80 to 240 kilojoules per mole, since it involves strong chemical bond formation. A tabulated difference between physical and chemical adsorption. Number 1, the forces operating in physical adsorption are van der Waals forces. In chemical adsorption, these are chemical bonds. In physical adsorption, heat of adsorption is low, about 20 to 40 kilojoules per mole, whereas in chemisorption, it is 40 to 400 kilojoules per mole. Number 3, the process of physical adsorption is usually reversible, whereas it is irreversible in case of chemical adsorption. Physical adsorption does not require any activation energy, whereas chemisorption requires activation energy. Physisorption takes place at the low temperature and decreases with increase in temperature, whereas chemisorption, the adsorption first increases with increase in temperature and then it decreases. Number 6, physisorption is not specific in nature, whereas chemisorption is highly nature specific. Number 7, the physisorption increases with increase in surface area of adsorbent. Chemisorption also increases with increase in surface area of adsorbent. Physisorption form multi-molecular layer, whereas chemisorption form unimolecular layer.